Décollage. Liftoff.
Welcome to the dawn skies here. We've got a Soyuz launcher with its 5 passengers. Here we are in Kourou at the European spaceport for the 9th and final launch of 2019. Now, we saw yesterday that the launch was postponed by 24 hours. The countdown was interrupted 1 hour before liftoff due to a technical problem. All of the safety procedures have been followed. The team has been working all evening and much of the night so that we could go ahead with the liftoff this morning. This is the 23rd Soyuz going up from the equator. It's the STA version today, 47 meters in height, 309 tons at liftoff, with a performance requirement of 3 tons, 65 kilos. And as I said, under the fairing, there are 5 passengers. First of all, COSMO-SkyMed Second Generation, 2 tons, 198 kilos. It's an Earth observation mission, and the mission will last 7 years. This will be followed by CHEOPS, 272 kilos. It's for space exploration and is a 3.5-year mission. Then we have OPS-SAT, 6 kilos, and EyeSat, 4 kilos. Both of these are science labs for 1 year. Angels weighs in at 19 kilos, and it's the prototype of the future constellation for Argus New Generation geopositioning. And this mission lasts 2 years. So that was a quick introduction. Let's go inside Jupiter now and back to Joshua Jean-Paul, who will be there for the English-speaking commentary. Over to you, Josh.
Right, Thierry, welcome. Our broadcast coming to you live, as always, from inside the big Jupiter Mission Control Building here in the heart of the Space Center. Jupiter's the center of all the action, and you can see behind us a lot of action going on as the team's here gearing up for the liftoff as the countdown proceeds. Much the same happening at the bases around the world where the mission is being followed. Coming up on about 17 minutes to liftoff time. Very happy to have with us Stefan Israel, Arianespace Chief Executive. Welcome, Stefan.
Good morning.
We won't keep it too long. We just have a few questions for you. First question. Soyuz 23 is the 9th and the last mission of the year for Arianespace. What makes it so special?
Yes, so this is the 3rd Soyuz of the year. The 49th Soyuz we do with our Russian partners from Baikonur and from the Guiana Space Center, and the 9th launch of the year. And this mission is very special for us because it is a mission for our European institutions, for Italy, it is the main passenger. It is COSMO-SkyMed Second Generation. For ESA, with CHEOPS under strong leadership from Swiss. And we have also 3 little babies, 3 CubeSat, EyeSat, OPS-SAT, and Angels, for ESA, for CNES, and for 2 innovative companies, Tyvak and Hemeria. So a lot of babies on board, and all will be okay.
All will be okay. All the babies going, as you mentioned, to sun-synchronous orbit. That's one detail. Can you give us some other details, some other facts and figures on the mission?
Yes, so we have made the decision approximately 5 hours ago to go to the final fueling operations of the launcher. We have checked with our CNES colleagues the weather, which is okay. And so now we are in the very, very last moment for preparing the launch. Everything will be okay for our launch at 5:54 and 20 seconds, and it will be a long mission. The missions will last 4 hours and 13 minutes. We will have 6 burns of our frigate upper stage. We will first liberate COSMO-SkyMed after 22 minutes. Then approximately 2 hours after, we will liberate CHEOPS, and almost 2 hours after, we will liberate EyeSat, OPS-SAT, and Angels. So we will have to be patient. We have 4 hours and 30 minutes of missions this morning.
Long mission this morning. I don't think we've ever had as much as a long mission.
I think it's one of the longer. When we make for Galileo, it takes a lot of time as well.
Okay, very good. Stefan Israel, many thanks. Stefan is going to take his place behind us in the fishbowl, and he'll be back with the speeches, the traditional speeches at the close of the broadcast. Countdown, of course, and not just a 3, 2, 1, push a button and lift off. It's a very complicated procedure, which is why we have many events going on as all the information flowing in here to Jupiter, monitoring the liftoff. We're going to stay in Jupiter because we like to introduce the key players that make the mission happen, and a lot of them are here in Jupiter. You're looking into the Arianespace High Command, called the Flight Desk. Heading up the team will be Stefan Israel, who has not made his way to his place yet, but will momentarily. With him, Roland Lagier, the Chief Technical Officer, and with them, Andrei Mazurin, Roscosmos Flight Director, the Russian Launch Authority. All right, we will leave Jupiter for the moment, go back outside to Terry for a look at the Soyuz ground facilities here in Kourou. Terry.
Yes, Joshua, I'm not very far away from you, just a few meters above, and I'm outside, and that means that a long way off I can see a distant glow in the Guiana night sky, and that glow is above the forest, and it's quite simply the Soyuz launch zone, which is up at CNES, which is some 28 kilometers from Jupiter, where we are. And at the launch zone, we're now going to see it, actually, thanks to the drone. At that launch zone, we've got all of the fueling facilities, the final assembly building, and also the massive flame trenches. And on top of this, you see Soyuz. There's also the Soyuz Launch Center. And among the people working there, you've got the Quick Look Telemetry Data Unit. And now we'll hear from Armel Girard.
Asks the Guiana Space Center to set up a ground stations network able to track the launcher and to receive its telemetry. This telemetry contains all the data and parameters collected on board and sent to the ground via radio frequency emission. For VS23 launch, this network features the following stations: Galio in French Guiana, Saint-Hubert in Canada near the city of Montreal, Nunosia in the west coast of Australia, Lucknow in India, and Mauritius Station on the Indian Ocean island. With this network, the launcher is followed during the main phases of the flight. Because of the duration of the mission, each station will be overflown at least twice. The data collected by these stations are immediately sent to the CDLS, the Soyuz Control Center in French Guiana, and to the Frigate Flight Monitoring Center in Moscow. The most meaningful parameters of the launcher are monitored in real time by Arianespace and Russian experts. These data refer to the propulsion of the launcher, its trajectory, and the flight control. In Moscow, NPO Lavochkin, experts in trajectory and ballistic, perform the calculations to assess the separation condition of the satellites and their orbital position. Our technical representative in Moscow for this flight is Antoine Courtois. He is particularly in charge of the delivery of the final orbital diagnosis to Jupiter Mission Control Center.
And all of the data is then thoroughly analyzed, and it'll make up the memory bank. You can imagine that there's an awful lot in that memory bank after 315 launches with Soyuz, Ariane, and Vega. We're now going to hand over immediately to Joshua. Joshua, we're going into a very significant moment in the countdown.
Right, Terry. At 11 minutes to go, the launcher's waiting on the pad. We're going to go back inside Jupiter to continue presenting the main players, the dramatis personae, the people making the mission happen. Two people you're going to be seeing a lot, and especially hearing from one of them, the mission director, Cyril Ponroy from Arianespace, and he's working alongside the range operations manager, a.k.a. the DDO. Tonight, Hugues César-Bogam in the role, and you're going to be hearing him calling out the key announcements on all the major milestones during the countdown and during the flight. Like now, he's going to shortly call out the 10-minute mark. That's the 10-minute mark, beginning of the automatic or the synchronized sequence. This is the moment when power passes from the ground to the onboard computers, making Soyuz autonomous. Last thing we want to show you, the green status panels on your screen there. They are a real-time summary of the different launch services provided by the base. Everything is green, which means, which is as it should be. Any problem, we'll get a red, and we'll have a hold in the countdown. We check these from time to time before lifting off. All right, our stage is set. You know all you need to know. I'm going to make my way to the broadcast booth, and we're going to go back to Thierry outside, who will close out our opening segment. Thierry.
Yes, indeed. We're now into the final part of the countdown. Everything's going ahead smoothly. Everything is green, as you can see. The launcher is becoming increasingly autonomous, and that'll continue right through to liftoff in a little over 9 minutes from now. Let's take a look at the campaign itself together with Cyril Ponroy and Klaus Zell.
Today marks the entry of the final phase of the launch campaign, which started on October 14th, with the unpacking, the pneumatic controls, some minor modifications of the thermal installation of the attitude control systems on frigate, followed by the autonomous electrical verifications of the versatile frigate upper stage. The pre-integration of the 4 lateral boosters, the first stage, with the core stage, the Block A, or also called the second stage of the Soyuz launcher, was performed during the second half of October. Final assembly and testing of the vehicle started on November 25th, some days prior to the beginning of the combined operations.
My name is Cyril Ponroy, the mission director for the flight VS23. The launch campaign began on the 16th of October, earlier than scheduled, due to a request from Airbus, who optimizes the transportation cost for CHEOPS by sharing the same Antonov than Tyvak, one of the passengers of the flight VA250. Angels, one of the auxiliary payloads, arrived also in the same Antonov. After the arrival, CHEOPS performed some health checks for 2 weeks and then began a standby phase. The satellite was transferred to the S5A through the clean corridor for the propellant loading. The fueling and the pressurization were performed in 1 day on the 23rd of November. After the meeting on the adapter, CHEOPS was encapsulated inside the Arianespace, the multiple launch structure for Soyuz. EyeSat arrived by freight on the Air France flight on the 21st of November. The preparation campaign lasted 3 days before being ready for the meeting. OPS-SAT, the third and last auxiliary payload, arrived by hand luggage on the Air France flight on the 27th of November. The 3 auxiliary payloads were mated on the Arianespace on the 13th of November. COSMO-SkyMed Second Generation, the main passenger, arrived by Antonov on the 12th of November for 3 weeks of preparation inside the S1A building. We transferred the satellite to S3B building for the propellant loading.
Frigate was brought onto the F-Cube, the frigate fueling facility, on November 7th for the pressurization of the helium vessels to flight level and the fueling of the starboard propellant tanks. After the final preparations, frigate was transferred on December 5th to the S3B, the spacecraft fueling and preparation facilities.
The Arianespace with CHEOPS, Angels, EyeSat and OPS-SAT was integrated onto the frigate on the 6th of December. Finally, COSMO-SkyMed Second Generation was integrated onto the Arianespace on the 9th of December, completing all the satellite activities.
The rollout of the 3-stage from the MIG building to the launch pad has been performed on D-3 last Thursday, as well as the transfer of the upper composite and the frigate from the S3B onto the launcher. A special thank you goes to all the operational teams for the huge efforts and contributions to take us through this very smooth launch campaign so far. Thank you for watching.
Back in the booth, we were supposed to go, as you heard 24 hours ago, we were delayed a day by a small technical problem, but all is well now and we're on our way. The 9th and last launch of the year for Arianespace, and it has been a busy year. We'll have a recap of all the 2019 launches coming up for you. And we have a very busy mission tonight, a multiple launch, 5 satellites, 7 upper stage burns. They've done that at Baikonur with the Soyuz, but we've never done it here. So tonight is a first, and we're glad you could share it with us. What is not a first, of course, is the Soyuz. Soyuz, I just learned, by the way, means union. The Russian launcher, going back to the very first days of the space race, the mid-60s, it has handled all types of missions. The DDO did not call it the Klushna start, but we do want to mention that. That's the key that's actually turned manually to start the final synchronized sequence. Another place besides Jupiter is very busy is the launch zone, where the management teams are. You saw Klaus Zell, who's the Launch Complex Operations Manager for the Ariane side, and you saw Alexander Sharavan heading up the Russian team. Work done out there carried by their teams, one team responsible for executing the flight chronology and the other for verification of the flight worthiness of the Soyuz vehicle herself. The Launch Complex Operations Manager heading up the group responsible for execution of the chronology, and he coordinates with mission control for final authorization to launch. So these people hard at work now in the Launch Control Center going over the final checks and the verifications to all parts of Soyuz launch system. 4 minutes to liftoff time. Some things to watch for at -2 minutes 35 seconds. You'll hear the DDO call out the electrical umbilicals. Those are cables on the satellites have been released. You may be able to see that. They drop into a metal basket designed for the purpose of retaining them. Here in Jupiter, you see the operational teams in the foreground, in the background, the invited guests. The operational teams, in fact, to launch Soyuz or an Ariane or a Vega, for that matter, we need also security people, we need support from the Army, we need firefighters, a lot of other professions. These workstations, staffed by teams in charge of the launcher, the satellites, and the space-based facilities. The room divided into two parts, as we mentioned. The seating area in the back in red seats 250. 3 minutes to go. Soyuz waiting. Countdown, we mentioned a very complicated process. Some argue it's the most intense part of the entire launch campaign. To get us here, many things have already had to happen. For example, -4.5 hours, we began filling the tanks with their hydrogen peroxide and liquid oxygen. At -1 hour and 35 minutes, that filling was completed. By the way, once the launcher is filled, we have 3 days to launch. Otherwise, the fuel begins corroding the vehicle, and we have to empty the vehicle of its fuel. The same is true for Ariane 5. DDO has just called out the largage, the jettisoning of those cables I mentioned for the satellites. About an hour ago, the gantry was moved back 80 meters. You can see it to the left of the vehicle. Coming up on the final ignition sequence. At 2 minutes, you may start to see the people here in Jupiter. Not quite yet, but in a moment. Yes, there they are. They're going to start making their ways out to the terraces. There's terraces on either side if you haven't been here, giving a fine look onto the launch pad, and they're going to get a bird's eye view of liftoff. -40 seconds, Soyuz will be completely autonomous because at that time power has been transferred from the ground to on board. There's the drone's eye view of the terraces that we mentioned. There's another on the other side of the building. Power being transferred from the ground to on board. The computer's taking over at -40 seconds. -35 seconds, the arms will retract from the launcher. You should be able to see that on the screen. That's a very exciting moment. The DDO will call it out. The DDO is going to call out.
DDO, attention pour -1 minute.
He's going to call out the 1 minute mark.
Stop, I0, -1 minute.
60 seconds to go. Give us a chance to say hello to our friends in Rome at ASI, at the Italian Space Agency. They're taking the broadcast out there. Also to our friends in Toulouse at the Cité de l'Espace. You're following us as well. Hi also to all of our partners here and in Europe and around the world. And to all of you following on the internet. And there's the mast.
À tous de DDO, attention pour le début de la séquence d'allumage lanceur.
We're ready to go. We're going to cut away. You'll hear the DDO call out the final countdown. Enjoy the launch.
Stop, I0, -20 secondes. Largage du mât VKM, allumage triétage, à tous de DDO. Attention au décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top décollage. Les paramètres au bord sont normaux. Bon fonctionnement des moteurs du premier et deuxième étage. Stabilisation du lanceur sur les 3 axes.
Well, fine shots. Always impressive no matter how many times you see Soyuz powering into the sky. 309 tons at liftoff. That's less than half the mass of Ariane 5. The boosters are the first stage. The boosters on the central core or second stage are burning now.
Les paramètres bord sont conformes à l'attendu.
As the DDO says, all is well on board. The boosters weigh 45 tons each at liftoff. Total mass of the first stage, 178 tons. Their engines running on liquid oxygen and kerosene. The same propellants used in each of the 3 lower stages.
Les paramètres propulsifs sont conformes à l'attendu.
The second, or the core stage, similar to the boosters, its ignition occurred on the launch pad. As you saw, the stage will burn for 4 minutes. Remember, Soyuz weighed 309 tons at liftoff after separation of her boosters, which you may be able to see by with the naked eye, but there's the onboard camera showing what it looks like.
Séparation des 4 propulseurs.
At separation of her boosters, she's down to 135 tons. So in less than 2 minutes, she loses more than half her weight. On the bottom of your screen on the left, our altitude, on the right, our speed. These figures coming in from the downrange stations. Galileo in yellow on the screen, on the left just disappearing. That's the local station here in Kourou. The data are received by the Russian teams in the launch center, then confirmed before being broadcast. Next up is jettison of the fairing. That's in about 20 seconds. Fairing measures 4 meters in diameter, stands about 11 meters tall. We can get rid of it now in 17 seconds because we no longer need the protection it gives the satellites during their ride through the Earth's atmosphere. At 100 kilometers up, we are out of the dense layers of the atmosphere. There's no more friction, no more heating, which can disturb anything to disturb the satellites. And there you see the fairing jettison. There's another half, which is out of camera range on the port side of the vehicle. This powered phase of Soyuz's first 3 stages will last about 9 minutes. Then the upper composite, called the frigate, that's the upper stage, with the satellites, will be separated. It takes over and does the rest of the work, completing the mission. Europe's space effort is a 3-way affair. Arianespace marketing and operating the launch services and the Ariane program. The European Space Agency funding new programs. And the French Space Agency CNES overseeing coordination of all space-based operations. Marianne Claire, you heard her here just at the beginning of the broadcast, new director of the space base since a month, roughly, and also the first woman to hold the role.
Confirmation de la séparation des 2 demi-coiffes.
The CNES site here, chosen in 1964 because of many advantages, not least among them a large opening on the water. We have 50 kilometers of coastline, which makes possible flying both north and east, north for sun-synchronous orbits like tonight, east for geostationary orbits. Coming up on separation of the second stage. There you see what it looks like on the animation and what it looks like on the onboard camera. 186 kilometers up. And we will have ignition of the third stage. The DDU has just called that out. One unusual aspect of the Soyuz, whereas with Ariane, for example, we separate the lower stage before igniting the upper stage, Soyuz does the opposite. The third stage is actually ignited 2 seconds before separation of the second stage. The reason being, the lower part of the third stage, called the skirt, is used to channel the flux of this third stage motor ignition down toward the stage below, where it rebounds, giving an added thrust, assisting separation. The third stage skirt is then separated 10 seconds later, and during those 10 seconds, Soyuz climbs 4 kilometers. In an older version of Soyuz, without the frigate upper stage, it's the third stage, which put the satellites into its initial Earth orbit. Our next film, and the first on our passengers, coming up on COSMO-SkyMed Second Generation.
Hi, I'm Véronique Loisel, and I am the Program Director for COSMO-SkyMed Second Generation at Arianespace. My work mainly consists in interfacing with our customer for all subjects linked to technical matters, but also contractual, communication, financial, insurance, and legal aspects. Our job is to respond at best at our customers' requests. As for COSMO-SkyMed Second Generation, the 2,205 kilogram main satellite was manufactured by Thales Arianespace in Italy for the benefit of the Italian Space Agency and the Italian Ministry of Defense. It is a dual system, civil and military, designed to address the requirements of both commercial and government customers, as well as the scientific community. COSMO-SkyMed Second Generation will be part of a constellation of 2 satellites, which aims at providing an enhanced quality of the imaging services to the end customers with respect to the current CSK constellation. Thales Arianespace is a very important customer and partner for Arianespace. Indeed, COSMO-SkyMed Second Generation represents the 162nd satellite manufactured by the company and to be launched by Arianespace. It will be also the 4th satellite to be launched for the Italian Space Agency and the 9th for Italy, comprising ASI, Italian MOD, and Telespazio.
You may have noticed that since the start of the mission, events are announced by the DDA with maybe a slight 1-2 second delay with the pictures you see on the animation. This is quite normal, nothing to be alarmed about. The information, that's telemetry and radar, coming into the ground stations, then sent by them here to Jupiter, have to be first confirmed by our Russian teams in Moscow. Then they come to French Guiana at the CVI, which is the Quick Look Telemetry Center, which relays them to the DDO here. So at certain moments there might be a short time lapse, nothing abnormal about that. We will be going up to the CVI for a visit later in the broadcast. The Soyuz we're using today, it's the most recent version, the Soyuz 2. Originally, you might recall, Soyuz was a missile called the R-7, the world's first intercontinental ballistic missile, ICBM, developed in 1953 by Sergei Kourou, who was the father of the Soviet space program. The Soviet R-series was modeled on the German V-2. On October 4th, 1957, R-7 put in orbit Sputnik, you will recall. There's the separation of the third stage. See what that looks like. And with that, we have come to the end of the first part of the powered flight phase. We're now awaiting confirmation of the first frigate burn. Saint-Hubert at the top of your screen. That's our next downrange tracking station. It's
Extension du troisième étage et séparation du troisième étage.
We're waiting for confirmation of the first frigate burn. There will be 7, remember. Some will take place during the break, so we won't see them. We're going to cut away twice at 2 moments during the broadcast. We need 7 burns because we're launching 5 satellites, and although all are headed toward a sun-synchronous orbit, each has to go into its own orbit, of course, and its own altitude. And an interesting mix of satellites for this mission, multiple mission tonight. COSMO-SkyMed, Earth observation. The scientific mission CHEOPS for the European Space Agency. And then in the final part of the broadcast, 3 CubeSats,
small ones, OPS-SAT, EyeSat, and Angels. We'll be describing each in turn. There you see, right on time, the first ignition of the frigate burns, coming at 470 kilometers up, roughly. Our speed, 6.2 kilometers. This first burn will last 11 minutes. The second burn will take place at plus 1 hour into the mission, and the third 51 minutes later. The frigate upper stage, produced by NPO Lavochkin, prime contractors. Mass at liftoff 6.3 tons, carries almost as much in fuel, 5.3 tons. The frigate stands 1.5 meters tall. Frigate is an autonomous, flexible upper stage, relatively recent addition, qualified in 2000. It has been designed to operate as an orbiter and thus extends the capability of the Soyuz, giving her access to all orbits, low Earth orbit, sun synchronous like tonight, medium Earth orbit, GTO, GEO, and escape orbits. It's independent from the lower 3 stages, since it has its own tracking telemetry systems, navigation, and guidance. Our second film on COSMO-SkyMed, up next.
The COSMO-SkyMed system consists of a constellation of 4 identical satellites equipped with a high-resolution SAR, synthetic aperture radar, operating in X-band. It is a dual civil and defense system designed to address the requirement of both commercial and government customers, as well as the scientific community. COSMO-SkyMed allows global coverage of the planet, operating in all weather conditions and lightning, and provides geolocalized images with extreme accuracy. The COSMO-SkyMed system is a flagship of Italian technology in the world. It is the only constellation of this type currently existing in the global level. It is founded by the Italian Space Agency and the Ministry of Defense and the Ministry of Education, University and Research. The first and second generation of COSMO system is a result and expression of the best skill of the Italian space industry. The second generation of the COSMO system will ensure the continuity in the services so far provided by the first generation satellites and ground segments, representing a real generational leap in terms of technology, performance, and operational life of the system, and providing new application possibility. Both satellites of the second generation are improved version of the original design. The COSMO second generation SAR is also an improved version of the first generation X-band SAR system. Thales Arianespace in Italy is the program prime contractor, therefore responsible for the development and construction for the entire COSMO-SkyMed system. Telespazio built the entire ground segment of this constellation, whilst Leonardo Electronics Division participates in the program producing state-of-the-art equipment that regulates and distributes the satellite electrical power. Thanks to the progressive growth of design and technological skills in SAR, Thales Arianespace came into the 90s with the development of the constellation COSMO-SkyMed. The satellite platform that was used in a variety of missions such as RadarSat-2 and also in the ESA Copernicus Sentinel-1 radar satellite. COSMO gave us also important commercial opportunity. We in fact have signed an important contract with Korean Agency for Defense and Development. And we hope to continue on this successful path with other commercial achievements in the future. Finally, let me take this opportunity to thank the Italian Ministry of Defense and the Italian Space Agency for continuing to trust in us as a partner. And also, let me congratulate with all Thales Arianespace team, all the employees that worked tirelessly to reach these great results in terms of milestone.
During the film, we were picked up by our next downrange tracking station, that's Saint-Hubert in Quebec. Soyuz heading north, we're no longer being followed by the Galileo station here locally in French Guiana. We're out of range. Saint-Hubert, located outside Montreal, the Canadian Space Agency has its mobile servicing system operations complex there, all kinds of training and tracking facilities for space operations and support. As we look at the COSMO-SkyMed team, their satellite will be separated in about 8 minutes, plus 12 minutes, I should say, plus 22 minutes, 44 seconds. COSMO-SkyMed is the fourth satellite to be launched by Arianespace for the Italian Space Agency, ASI. The three others, two were launched on Vegas. That was Prisma and Lares on the very first Vega mission. And Athena Fidus went up on an Ariane 5. Our next film on the first passenger will give you an idea what the satellite will do once it's in place. Nice illustration during the film of how the satellite uses its spot beams. All proceeding normally on board at 19 minutes into the mission, 16 minutes to go in this first part. A note on the launch pad from where we lifted off, 28 kilometers from Jupiter roughly. It's the 7th in the world, 7th Soyuz pad, and the most recent until about 3 years ago. There are 2 Soyuz pads at Baikonur, 4 at Plesetsk. A new pad, the world's 8th, was built in Russia at Vostochny with a gantry, and the gantry is only used here at the CSG and at the new site at Vostochny. We're coming up in about 30 seconds on extinction of the first frigate burn, and you'll hear the DDO call out the milestone. Some other Soyuz facts, I'm sure you might recall, besides orbiting the first artificial satellite Sputnik over 60 years ago, 1957, of course, the first man in space, Yuri Gagarin, 1961, lifted by a Soyuz, the first woman in space, the first spacewalk. Soyuz also holds the world's highest demonstrated reliability record, close to 99%. That's pretty remarkable. You see the first stage engine shutting down, so that burn is over. Soyuz positioning herself for release of the first satellite, CSG-1. The frigate is on the extreme left of the vehicle. Our next film on COSMO-SkyMed, first maneuvers after separation.
Giancarlo, you are the COSMO-SkyMed Second Generation Program Director at the Italian Space Agency. Could you explain us the mission in a few words?
COSMO-SkyMed Second Generation is an Italian national Earth observation program. It's based on a constellation of X-band synthetic aperture radar satellites. It's a joint initiative between the Italian Space Agency and the Italian Ministry of Defense, and enables through a single system to fulfill both military and civilian national Earth observation needs. With the second generation, Italy will continue to benefit of a key space infrastructure that allows observing our planet in night and day and all weather conditions, providing also additional capabilities to the first generation, still in operation since more than 10 years.
Thanks, Giancarlo. Andrea, you are the Satellite Mission Director. How would you summarize the different steps which will happen after the separation?
Concerning the commissioning of the satellite, we will follow a nominal process. During the LEOP, the satellite will deploy the solar array wings, the X-band downlink antennas, and the phased array antenna of the SAR payload. Before Christmas, we will enter in the in-orbit test phase. The satellite will reach its final orbit, a down-dust synchronous orbit with an average altitude of 620 kilometers, and we will perform the calibration of the electronic beams of the SAR payload. In springtime, we will complete the handover with the operational teams to allow the satellite to start to provide the services to our end users.
Approaching separation of COSMO-SkyMed. COSMO-SkyMed, you can see on the left of the vehicle. The 9th satellite to be launched by Arianespace for Italy. 2 more Italian satellites to be launched in the Arianespace backlog. There will be a CSG-2. There's also an auxiliary payload. CSG-1 built by Thales Alenia Space, the 161st satellite launched by Arianespace, manufactured by the group. And there you have the scheduled separation. We're waiting for the DDO confirmation. Again, we mentioned the slight
fin de manœuvre d'orientation
lapse
au profit du satellite haut COSMO-SkyMed.
Before we get confirmation, always a moment of high concentration in Jupiter and around the world as at all the posts, the teams are monitoring their satellite. Separation, of course, marking an end as well as a beginning. But some of the COSMO-SkyMed team has been on the project for years. For others, work will be just beginning.
Confirmation de la séparation de la charge utile haute COSMO-SkyMed Second Generation.
All right, and you see the DDO confirming. And you hear the applause. The first good news of the night, Soyuz successfully separating her first passenger, the 2.2-ton COSMO-SkyMed Second Generation 1. For the Cosmo people, you can see their smiles, a moment of triumph, watching their satellite leaving the mothership on its way to begin life on orbit. The satellite's early orbit maneuvers will take 1 week. In-orbit testing will be completed by next March. Start of operations scheduled for June. There will be a second COSMO-SkyMed we mentioned to be launched next year, I believe, and Ozzy tells us that full operational capacity with the 2-satellite fleet will be available in mid-2021. And on that note, we're going to go to a launch replay, and you can relive those very exciting moments as Soyuz left the pad almost half an hour ago. frigate is moving into her first ballistics phase. We will suspend the broadcast momentarily while she does so and give you a break. We'll be back for more of the mission. Remember, 4 more passengers to be launched. You can stay connected during the break via the internet or watch events on the screen. Here in Kourou, the VIPs and visitors watching from the other observation sites at the base will be joining the crowd here for a breakfast. Everyone will return to their sites, to this site, for the second part of the broadcast, which will begin at plus 2 hours and 1 minute. So enjoy the break. We'll see you back here then.
Bonjour. So, hello or hello again to everybody. Day has indeed broken here in French Guiana, and we're back on the air for this Soyuz 23 mission from the Guiana Space Center. We are really delighted to be back with you. I'm here with my colleague and friend Joshua Jampol, who is giving you the English commentary for this broadcast. It's a very long mission, but it's absolutely fascinating. Joshua, can you quickly remind us what are the main things that have happened since the start of the mission when the liftoff came 2 hours ago?
If you just joined us, you missed some of the action, but not to worry, plenty more to come. Besides, we're going to recap it for you in just about 10 seconds. You'll be able to relive once again the shots of liftoff. We had successful liftoff of the Soyuz on time at 5:54 and 20 seconds local. the 9th and final Arianespace flight of the year, and the 3rd Soyuz of 2019 roared off the pad majestically, rising into the skies above French Guiana, lost in the clouds, in the low clouds momentarily, but reappearing once she gained some altitude. Following that, everything worked flawlessly. The boosters were released on time after having done their job. Then came the fairing, separated at 106 kilometers up. The second stage completed its burn and got separated, followed by the third stage, released at plus 8 minutes and 49 seconds. Then the upper stage, the frigate, took over, igniting its engine for the first of 7 burns to position itself. Canadian ground station picked up the station. COSMO-SkyMed separated at plus 2244. The Australia station acquired the signal, and the second frigate burn took place before the Galileo station, Canada, acquired the signal again as Soyuz completed her first orbit of the Earth. The adapter covering the next passenger, CHEOPS, was released. The Quebec station acquired the signal again. Frigate burned her engine a third time, and finally we were picked up by the Lucknow station in India. So that is where we are. The first part of the mission was letter perfect. Thierry.
We just...
Yes, Josh. The second part of the mission is now going to be totally devoted to the second passenger, in other words, the CHEOPS mission, which is the exoplanet mission. And the name of your guest?
Second passenger is from the European Space Agency. And when we return to the booth, well, we're in the booth, when we return to after the film, I'll be joined by a special guest, Kate Isaac, who's the space scientist. I think you can see here alongside of me, space scientist for the mission. We'll be able to tell you all about the mission until the satellite separation. So a lot coming up. Don't go away.
So on the French side, I will be with Willy Benz. But let's take a look at CHEOPS together with Fabrizio Fabiani.
Hello, I'm the Arianespace Program Director for CHEOPS. After the separation of the first satellite, we are now waiting for the next step of the mission, that is the separation of the second passenger, CHEOPS. And it will be delivered at an altitude of 700 kilometers in a down-dusk sun-synchronous orbit to observe bright stars already known to host exoplanets. This orbit has been selected to ensure stable thermal conditions and minimize the effects of the Earth's stray light on the scientific measurements.
CHEOPS, the Characterizing Exoplanet Satellite, is ESA's first mission dedicated to the study of extrasolar planets. CHEOPS will observe bright stars that are already known to host planets, measuring small brightness changes due to the planet's transit across the star's disk. CHEOPS measurements will allow to characterize planets with a size similar to Earth, deriving accurately their radius and allowing to calculate their density. The prime contractor for the design and construction of the spacecraft is Airbus Spain. The payload, based on an optical telescope with an effective aperture of 30 centimeters, was developed by a consortium of ESA member states under the lead of the University of Bern. CHEOPS is the first fast-track mission in the ESA science program and is expected to operate for 3 years and a half, providing state-of-art measurements to the scientific community.
I will come back to you later on for describing the mission of the other 3 passengers of this VS23 mission.
We want to welcome Kate Isaac from ESA, the European Space Agency. You are project scientist from CHEOPS. I get that right?
Indeed.
All right. For how long have you been project
I've been working at ESA as a project scientist for 6 years.
All right. So as project scientist, tell us a little bit about your role in the project. What do you do?
I make one of the links between science and engineering. And to do this, I work very closely with the PI of the mission, Willy Benz, who's in the booth next to me, and also the project manager, Nicola Rando, at ESA. And what we try and do is to make sure we get the best science, taking into account the practical constraints, engineering constraints, budget, and of course time. And this means working closely with scientists and engineers from the consortium and all over ESA.
Tell us just briefly, 15 seconds, about the consortium, because that's an important part.
Indeed, the consortium is made up of 11 countries that are member states of ESA. It's led by Willy Bentz from the University of Bern, and the consortium makes up a partnership between Switzerland and ESA. And they can contribute to the hardware, the software, and the science of the mission.
All right, up next, the first in a series of films on CHEOPS. Back with more with Kate afterward.
This is CHEOPS, a specialist satellite with a single instrument, a powerful camera or photometer. It'll record the light from stars orbited by known exoplanets. CHEOPS is designed to investigate what these planets are like.
We'll be focusing on smaller planets, so Earth-sized to Neptune-sized planets, which have been found by other missions, such as Kepler, to be very abundant around other stars, sun-like stars, something which is not so much the case in our own solar system. So it's a big question. What are these smaller planets? What are they made of?
CHEOPS will do this by measuring the variation in light caused when an exoplanet passes in front of its host star.
CHEOPS is about taking the next step in investigating planets beyond our solar system, and in particular aims at providing a reliable and accurate measurement of the size of the planets, and from there be able to derive their density and therefore their composition.
The Space Telescope will orbit some 700 kilometers above the Earth, with its camera always pointing towards the night side. This will limit the effects of any stray light disturbing its measurements. CHEOPS is a relatively low-cost and low-risk mission, since all its elements have already been proven in flight. Nevertheless, building a satellite to obtain precise measurements of light from alien stars has been a complex technical challenge.
The instrument was designed to be able to perform accurately over long periods of time, and the satellite was designed around the instrument to guarantee these stable conditions. As you can see, the satellite has a sun shield protecting the instrument from the direct sun illumination, and this is very important to allow the proper thermal stabilization of the detector inside the instrument.
So far, more than 4,000 exoplanets have been discovered by telescopes on Earth and in space, with the number rising almost every week. CHEOPS will give us an insight into the nature of these planets, and even whether some of them have the potential for life. In doing so, this small satellite will help us take the next step in answering a fundamental question about the universe. Are we alone?
Let's talk a little more about the satellite now. Maybe we should start with exoplanets. They are planets outside our solar system. Why do they need a dedicated ESA mission?
Yeah, firstly, indeed, an exoplanet is a planet orbiting a star other than our own. The first exoplanet was found back in 1995. It was a sort of Jupiter-sized planet orbiting quite close to its host star. And since then,
a mission, or was it from the
telescope? It was from the ground. It was from a telescope on ground. And since then, many have been found also from the ground. But what we're really interested in is the smaller planets, Earth to Neptune-sized planets, trying to find out what they're made of. And planets this small are difficult to detect from the ground. We talked about the transit technique earlier, and a Jupiter-sized planet transiting a star the size of the Sun would block about 1% of the light.
When you say transiting, just very quickly, it means going across. It's like you'd see an eclipse.
Indeed, it's the same. It's the same phenomenon. But an Earth-sized planet would block 1/100th of that, so 0.01%. And that we simply cannot do from the ground. For that, we have to have a space mission.
So we have to fly half telescopes, half missions, I guess, is the...
The different techniques are used to find planets, and these have different selection effects. We find different sized planets orbiting different types of stars.
Okay, our next film on how CHEOPS will look for exoplanets.
Thanks to space telescopes like the International Hubble mission, we know there are some 2 trillion galaxies in the observable universe, and hundreds of billions of stars in our galaxy alone. Now technology is revealing planets orbiting many of these stars, and we're beginning to understand what they're like. In 1995, Michel Mayor and Didier Queloz from the Geneva Observatory co-discovered the first ever exoplanet orbiting a sun-like star. This year, they won the Nobel Prize in Physics for their work.
In these days, I was using a technique that we call radial velocity, which is observing a star and looking for any change of speed in the star. Well, since then, the field has just exploded. As you may know, there is really now thousands of exoplanets. There are a lot of planets known to be transiting, which means the planet goes right in front of the star. And that's these techniques that we're using for the CHEOPS mission.
Thanks to ground-based observations and planet-hunting missions such as Kourou and Kepler, more than 4,000 exoplanets have now been discovered. They range from small rocky planets to gas giants larger than Jupiter. CHEOPS will be targeting known planets between the size of Earth and the icy giant Neptune, which has 4 times our planet's radius. The mission will probe the nature of these exoplanets and begin to answer questions such as whether any of these alien worlds could support life.
CHEOPS's aim is to measure the size of already known exoplanets. So it's not a discovery mission. It is really aimed at precisely measure the size. And once we have the size and possibly the mass, we can derive the mean density, and from then we know a little bit what the planet is made of.
Data from the orbiting space telescope will be processed in banks of computers at the Geneva Observatory, home to the CHEOPS Science Operations Centre, where scientists will also decide which exoplanets to target.
We're sending the observation program to the Mission Operations Center in Madrid, where then the information is uplinked to the actual instrument. The instrument is configured to observe the star, and then the telemetry, the data is downlinked to the Mission Operations Center and right away forwarded to us here in Geneva, where we then can do the data processing, archive the data, and then provide it to the scientists all over Europe and to the world.
By making repeated observations of several hundred planets, CHEOPS will provide an important insight into the inner structure of exoplanets, how they form and evolve, and whether any are even a little bit like the Earth.
The first film talked about 4,000 exoplanets, I think, have already been found. I can think of a couple of the many, many missions. There was a CNES mission, Kourou, a couple of years back, a couple of NASA flights, Kepler and TESS. What will CHEOPS do that all these missions and all the other telescopes discovering from the ground, as you mentioned, have not been able to do? I guess the question is what makes it special?
It's a very good question. The missions you mentioned before were all designed to find planets. And the way they did this was to use transit photometry, technique we've talked about earlier. Yeah. And they stared at fixed points in the sky for days, months, even years, looking for the transit of these exoplanets. What CHEOPS is a follow-up mission. And what we will do is to follow up on known exoplanets. So exoplanets that are orbiting bright stars. We know when and where to point, and that's key. We look at bright stars so that we can measure the mass from the ground. And by combining the mass with the size, and from the size we get the volume, we're able to say something about the density, make a first measurement of the bulk density of the planet. And that's a first step characterization. We also have the potential to identify targets which are particularly special to be followed up with future missions, planets which have thin atmospheres, perhaps like the Earth.
Our last film on CHEOPS now, a look at the Operations Center in Spain.
An antenna at the National Institute of Aerospace Technologies, INTA, on the outskirts of Madrid. This will be CHEOPS's primary connection to the Earth, a vital link between the Space Telescope and mission scientists. Over the past year, the international team at the CHEOPS Mission Operations Centre has been preparing for launch, training for in-flight activities, including commissioning, commanding and monitoring the satellite, as well as testing communication systems to ensure the smooth flow of scientific data.
We actually don't train ourselves only for the standard or expected situations, but also for unexpected situations and real problems that may happen. So that's the reason why we have two shifts, and we try to create problems for the other shift so that they don't know what's going to happen in the simulations, and then we fake that something wrong is happening and they have to find out and of course sort it out.
In the critical phase shortly after launch, when CHEOPS is safely in orbit 700 kilometres above the Earth, the mission operations team will ensure the satellite is in good health before switching on its telescope.
During this time, it is important to have more visibility of what is happening in the satellite. So ESA will provide more ground stations. So instead of just 4 or 6 passes, 6 times you see the spacecraft during the day, you will have one contact with the satellite each 100 minutes. So it's more easy to see that everything is okay and to solve any problem. That's why during this phase we will send commands not only from the routine ground station but also from ground station from the Antarctica, from close to the North Pole.
Everyone at the Mission Operations Centre is planning for a smooth mission, but the team will be well prepared for any surprises.
Yeah, thinking of surprises, you've been project scientist for 6 years. I imagine in that time you've been faced with some challenges. Are there any that stand out?
A very interesting challenge that we had was on the ground segment, which you heard a little bit about now. This is used to control, operate, talk to the satellite, and collect the data. It's sort of everything that's on the ground apart from the satellite. The complexity was that there were 6 different teams working on the ground segment. The science operations team in Geneva, that you heard about, the instrument team, the mission operations center, the Airbus, the satellite providers, and also ESA.
So how many people in all?
That was six different teams.
6 teams. But how many people?
Oh, more than 30 people.
Okay.
And the final details for each of the different elements were coming at different times for the projects. People needed them at different times, but the information was coming a little bit out of sync. And it was not always convenient for everybody, nor easy to work with, but we got there and we have an efficient ground segment now.
Great. How would you say CHEOPS fits in with the overall ESA scientific program, which is very vast?
CHEOPS is the first of 3 missions that ESA will have to explore exoplanets. The next is Plato, which is foreseen to launch in 2026, and will find and characterize terrestrial-like exoplanets.
That's a discovery mission.
It's a discovery and a characterization mission. And what it'll look for in particular is planets that have a surface temperature which is that sufficient to find water that's in a liquid form at the surfaces. There'll then be Ariel, which is foreseen to launch in 2028, and that will do a dedicated survey of the atmospheres of about 1,000 different planets, looking for the molecules in the atmospheres.
Okay, let me just interrupt you briefly. As you can see on the screen, we've had our 4th frigate ignition. We're right on target at 710 kilometers. This is a short burn of less than 1 minute. The frigate is positioning CHEOPS, your satellite, Kate, for separation in about 3 minutes. And in just about a second or 2, you will see the engine shut down. There you are. So we've had our 4th burn. The DDO should confirm that. So we are approaching the big moment. So you're probably full of suspense, so I'll keep you talking so you won't be thinking about the suspense. The satellite's lifetime, 3.5 years. That's not long. What are you going to do in 3.5 years?
Well, it may not sound like a lot of time, but we're going to do a lot in that, in those 3.5 years. We hope to observe about 500 exoplanets. Some will be very well known. Some are placeholders for future discoveries, including targets which will come from tests or other surveys from the ground.
Placeholders meaning?
Placeholders meaning that we have some time reserved to insert those new planets into the schedule.
Okay.
So we'll be following up on some that you may have already heard of. For example, 55 Cancri E, which is a very hot, small planet. It's hot because it has an orbit which is very close to its host star. We don't know what it's made of yet, really. Is it rocky, lava even? And also then HD 97658b.
Why do they have these names? I mean, can't they be called Mary or
They come
Jack?
from catalogues, and it's a catalogue number, similar to a telephone number, one could say, a way of identifying the stars. This target is a small mini Neptune-like planet, so it's a scaled-down icy planet. And lots of follow-up. We're a follow-up mission. We'll study the clouds in atmospheres of very close-in puffy Jupiters, possibly find new planets, even exomoons or rings like those around Saturn, although that will be tough. So let's see.
All right, we have about a minute before separation. Let's talk about the data that you're saying that we'll get from the satellite. It will all be made public, I imagine?
Eventually, in the first instance, it will go to the people who proposed to make the observation. So the consortium in most cases, but then also scientists from the community who proposed to do their science. After about a year and a half, the data will then be public, and it will be available through an archive at Geneva.
Available to anyone? Imagine I'm a scientist, I'm outside the consortium. Can I get access to the data?
Anyone can access the data, indeed. It's free for everyone.
Okay. You're due in just about a minute for separation.
Maybe I can say something about the guest observers program. We have a program which enables scientists from outside the consortium to use CHEOPS to do their exciting science. They can choose to observe whatever they wish to do. It's up to them, providing it's somewhat different in choice of target from those chosen by the science team. So it's a very nice opportunity for people to make use of the exciting capabilities of CHEOPS.
All right, any researchers out there want to use the data, contact Kate Isaac at the European Space Agency. Meanwhile, we have 20 seconds before separation of your satellite. What's going through your mind right now?
Oh, quite a lot, actually. It's interesting thoughts, how we've gone from ideas to paper to metal to launch in a period of, well, more than 6 years before I even started on the project and thought of what's to come. Very exciting.
It is very exciting. We have the scheduled separation of CHEOPS. You saw it on the animation, but we're, of course, waiting for confirmation by the DDO. Again, remember the information, a slight delay, because it has to come halfway around the world. Separation of CHEOPS, the moment that we've been waiting for. It's always a very, you don't want to say stressful moment, but it's a concentrated moment before satellite separation.
Confirmation de la séparation de la charge utile CHEOPS.
Woohoo!
The applause you heard was Kate Isaac clapping into her microphone. She has a big smile on her face. A big moment for you.
Yeah, that's very exciting. That's very exciting indeed. The next few days are going to be very interesting. We're going to be working at the Mission Operations Center to check out the spacecraft, and then once that's done, everybody will have a very well-deserved Christmas break. Then we're back in the new year to exercise the instrument and also the science operations team. Check that the instrument has survived the launch, to see how it performs, and look to see then how we're going to actually command the instrument and process the data, which is the end product that we're all very much looking forward to getting.
Well, congratulations to you, Kate. Just a final, we are going to have to cut away just a final, very quickly, a message to the team out there.
Very big congratulations and thanks to the very many people in the consortium, in Airbus, across our industrial partners, and as well, of course, here at CSG and ESA. Really looking forward to receiving the data that we'll get, and yeah, amazing.
All right, very good. We're due to pick up the signal from the Troll station. That's Antarctic or Arctic?
Arctic.
In the Arctic city. Okay. For more on CHEOPS, we're going now to Dominique Detain of ESA. That's he's your colleague, who has a special guest. Kate and I will be back for some final words.
installation of Pegasus in, well, it was in '95. So first of all, what is your feeling now?
I think it's great. I mean, we started this project more than 10 years ago, and now that's it. We are in the sky, so it's great. Yes, very excited.
Let's take us back to the origin. How did it start, all this story?
Well, it started by mistake, because actually nobody was expecting to find such a short period planets. And here it is. We have plenty of transit, and we have great science now to go.
You were not looking through a telescope. It was different. You were looking at data. It's not that simple.
Well, I think it has been years we not use the eyes anymore. We're using computers, detectors, so this is what it is, astronomy right now these days.
De visibilité de la station
in the Observatoire de Haute-Provence, where all this was taking place, you were checking data, you were like archaeology in the data?
Oh, it was not archaeology, it was really processing the data with big computers and trying to make sense to them. That's what it works, that's how it works.
So you discovered it before it was announced several times. How was this process?
Or to detect a planet, or it takes some time. You need to measure again and again and to detect the effect of the stars. Either you see the motion of the stars, or in this kind of CHEOPS, you see just the transit when the planet goes in front of the stars, and you use this event to detect the planet and to learn something about the planet.
So for you, there was a good girlfriend which was called Elodie.
Yeah, Elodie was an amazing instrument. It was a product of a fantastic team by Observatoire de Haute-Provence. By the way, I mean, I send my thanks to all these people that have been working great to have this instrument and the many others that we've built since then.
So you discovered it in a different way than what CHEOPS will be doing. You got the Nobel Prize. I think everybody knows that, and congratulations. But when in your speech in Stockholm, you said there are three main questions. One is, how do planets form and evolve? You have an answer now, or it's just CHEOPS will help us?
Well, that's exactly the purpose of CHEOPS. We have so many planets, so different. We have this super Earth, mini Neptunes, and we don't really understand all these systems. So that's the purpose of CHEOPS, by providing new data, very precise data, to understand a bit better and to understand the formation of the history of this system, and also to learn something about yourself.
And there's also another question, how diverse are the planetary systems?
Well, we know they are just amazingly diverse. So I think there is so many planets of all kinds that we just have to take a breath right now and try to make sense to all of this and try to get a global understanding about this many population of planets we're facing.
And the last question you had is, well, is there life out there?
Well, I mean, we are on our way to life. I mean, this is not an easy question. It's not an easy answer, but there will be steps. And the first step is trying to understand the planet, the planetary structure, possibly the planetary atmosphere. CHEOPS is the first step towards this. Hopefully, we'll know better about the structure of the rocky planet or the mini Neptunes, and we have a better understanding of the formation process of these systems. And then later on, there will be further instruments, more missions, more programs that will dig out the spectroscopy of this planet. And one day, who knows, we will have something out of this system.
Michel Mayer mentioned the fact that, asked also this question, is life a cosmic imperative?
Well, I don't really know that. I mean, I tend to be a scientist. I base my rational thinking on facts. And let's find life, and we'll talk again.
Okay, so let's go back on CHEOPS. You are the chairman of the science team. So what does that mean?
Well, it means there are a lot of great scientists working on CHEOPS. I'm just trying to make sense to all this global activity and trying to make sure everybody can express the science, the result, what they want to do in the best way. It's a bit like a big orchestra, and symphonic orchestra. I'm just a conductor, but I have plenty of solists and great scientists working on the mission, and many of them are right here. So I'm really very excited to start working on the data in a couple of months now.
And the CHEOPS is just the beginning, because we have at ESA following missions.
Oh, yeah. I mean, this is just a long series. And CHEOPS is the first one dedicated to exoplanet in ESA. I'm glad this is happening right now. And we have then Plato, we have Ariel, and I hope we will have further missions that is going to go to direct imaging, because I think the future is to take picture of this planet to get spectroscopy information directly from them. And that's for the future. That's for the next generation of students. If there's some listening to me right now, there's a lot of work to do, and it's really fun to work on that topic.
Didier Queloz, thanks a lot, and of course we'll be following that. We are now waiting for the rest of this mission, with many more to come. Thank you.
Thank you.
we are going to close out the second part of the mission because Soyuz is going into her second ballistics phase. We'll cut away again. Before we do, Kate, one last question. DJ Kilos had the question. I have it for you. You work in exoplanetary research. Do you think there's life out there?
Yes, I do think there is life out there, but that's a qualified yes. We have a vast universe. There will be life somewhere, sometime out there, but when and whether we'll find it, I don't know. That's
all right, so watch this space.
Watch this space.
All right, good luck with the project. Kate, Isaac, Avisa, many, many thanks. We're going to leave you again, as we said, the mission not over. We still have 3 CubeSats to orbit. That's coming up. The frigate is going into a second ballistics phase to position them for separation. We'll be back in about an hour and a half, plus 3 hours and 51 minutes for the final part of the flight. Still a lot to come. Don't miss it. Enjoy the break. We'll be back.
Réacquisition de la télémesure par la station de New Norcia.
Jean-Paul back again with Bouvard for the exciting conclusion of our very complex multiple Soyuz mission tonight with 5, count them, 5 satellites. We've orbited 2, COSMO-SkyMed for the Italian Space Agency and CHEOPS for the European Space Agency. Now, in any standard launch, that would be plenty, but tonight is no standard launch. Remember, we have 3 CubeSats to go. We still have an hour in the mission. The 3 CubeSats, OPS-SAT, EyeSat, and Angels, small satellites at roughly 4, 5, and 19 kilos, but an important part of the mission. CubeSat, by the way, is a miniaturized satellite, research usually. Over 1,000 have been already launched into space. So all that's coming up in about 15 minutes. Soyuz still has a lot of work to do, still a lot of action ahead. Meanwhile, looking back, while we were on the break, we had the 5th frigate burn. What else?
Et oui, un 5e allumage pour frégate. Il y en aura encore 2 autres. Et on verra ça tout au long de cette mission frégate. Et ces passagers ont été pris en charge successivement, il faut le préciser, par New Norcia, station du nord de Perth, en Australie, puis Saint-Hubert-Gatineau dans la banlieue de Montréal, Québec, et puis il y a peu par Lucknow, à nouveau, la station au nord de l'Inde, la capitale de l'Uttar Pradesh. Et puis on a eu des nouvelles de la station norvégienne de Troll,
a Norwegian station in the Antarctic that is in very good communication, picking up the telemetry from CHEOPS, ESA and Switzerland. So everything's looking fine, Josh.
On a la suite? Oui. La suite, c'est CubeSat.
And the next is?
Coming up to get us underway in the third part of our bilingual video transmission. Take a look at the 3 satellites now. We'll be back.
Yeah.
Nice to meet you again for the next step of the mission, that is the separation of the 3 auxiliary passengers Angels, EyeSat and OPS-SAT. The first one, Angels, Argos Neo on a generic economical and light satellite, is the first made-in-France nanosatellite. Angels is a 12U CubeSat. It is jointly financed and developed by the French CNES Space Agency and Hemeria, affiliate of Nexeia. The satellite is fitted, among the others, with a miniaturized Argos Neo's instrument, which is 10 times smaller than the equivalent previous generation device.
Being the payload developed by Thales Arianespace and Stirlings, Angels will join the current constellation of Argos instruments. The second one is EyeSat, a student CubeSat which belongs to Janus, Jeune en apprentissage pour la réalisation des nanosatellites des universités et des écoles de l'enseignement supérieur, a CNES program that supports French universities in developing their CubeSat projects. The specificity of EyeSat is that it has been developed within the French Space Agency since 2012, with more than 250 students involved. EyeSat, a 3U CubeSat, is equipped with the small homemade telescope IRIS and will observe the zodiacal light. The third one, OPS-SAT, will be the first satellite launched by Arianespace for Tyvak on behalf of ESA. Tyvak offers access to space by providing end-to-end cost-effective space systems, using agile aerospace processes and accelerating on-orbit access. Tyvak International of Italy provided the deployer and launch service for OPS-SAT on behalf of ESA. OPS-SAT was developed by the Graz University of Technology with subcontractors from Austria, Germany, Poland and Denmark. It is operated by ESA from the European Space Operations Center in Germany. I would like to thank all the teams involved in this mission for their professionalism and spirit of cooperation. Thank you.
Well, 2/3 of the mission have been completed. OPS-SAT and EyeSat are our next passengers, but not our last passengers. They will be separated together at plus 4 hours and 10 minutes. That's just 14 minutes away. OPS-SAT is a CubeSat and the first satellite to be launched by Arianespace for the Tyvak International of Italy. I hope I'm saying that right. It might be Tyvak of Italy, on behalf of the European Space Agency. It arrived here in French Guiana November 27th. It was assembled on the platform along with Angels and EyeSat 3 days later on the 30th of November. They are calling it the first free-for-use in-orbit testbed for new software, applications, and techniques in space control measures. And now a film on OPS-SAT.
OPS-SAT is a tiny CubeSat, just 30 centimeters high, but containing an experimental computer many times more powerful than on any current ESA spacecraft. It's the world's first mission dedicated to testing satellite operations technology, software and techniques in the harsh environment of space. To develop innovative new software for future missions, testing must ultimately be performed in orbit. Experimenting with operational satellites is too risky, too costly, and failure is never an option. With OPS-SAT, failure is an option, as the satellite can be recovered and rebooted after each experiment, enabling developers to learn from their mistakes. This flying laboratory will be controlled from a new small footprint lab at ESA's ESOC Mission Control Center in Darmstadt, Germany. Here, engineers, students and the European space industry can come and test their new mission control software and concepts in space. By taking control of a satellite in orbit, their experiments can go far beyond the limits of what is possible on the ground. Over 100 companies and institutions from 17 European countries have already registered experimental proposals to fly on OPS-SAT, demonstrating the mission's value to the spaceflight community and industry for innovation and experimentation.
Turning to EyeSat, the 16th satellite launched by Arianespace for CNES, the French Space Agency. Angels will be the 17th. The others, by the way, include the Spot Series 1 to 5, Topics Poseidon the Ocean Observer, 2 Pleiad missions by Soyuz in 2011 and 2012. With Angels and CHEOPS tonight, Arianespace has launched 130 missions and 159 satellites for European institutions and 7 countries. So Arianespace at the service of European space science. EyeSat with 3 objectives. It'll observe zodiacal light, that is the phenomenon of sunlight scattered and reflected off dust particles. It'll demonstrate new satellite technologies, and it will train students in space engineering professions. To do this, it carries a small space telescope, weighs about 4 kilos in orbit. Over to a film on EyeSat now. You'll be hearing from CNES President Jean-Yves Le Gall.
Hello. With the launch of Angels and EyeSat, CNES is proving once more a pivotal player in launchers, satellites and applications, the three main sectors of space. This launch underlines the fantastic versatility and flexibility of the Guiana Space Center, capable of launching all kinds of payloads. One of CNES's 4 centers of excellence, the CSG, is among the most sophisticated and effective launch bases in the world. And it is set to stay that way after the historic decisions regarding Europe's space program on 27th and 28th of November in Seville. Angels and EyeSat also illustrate CNES's impressive ability to innovate. Angels, a demonstrator for the first series of French commercial nanosatellites, was designed, developed and built in a little over 2 years, thanks to a unique partnership between several French SMEs. It is carrying the highly miniaturized, low-cost Argos Neo instrument, the latest in line from the famed Argos family. With Angels, we are thus moving into the burgeoning commercial nanosatellites market. EyeSat, meanwhile, is serving our ambition to pursue in-depth educational projects with students from engineering schools and universities and prepare them for careers in space engineering. Together, these 2 missions are opening up the field of space applications, especially for the Internet of Things. The future CNES constellation of nanosatellites derived from Angels is set to serve new applications for agriculture, logistics, fisheries management, sea rescue and more. Just days after the Seville conference, whose historic decisions marked a giant leap forward for Europe, CNES is showing once again with Angels and EyeSat that it is at the cutting edge of innovation and continuing to lead the way forward.
CNES President Jean-Yves Le Gall, of course, former head of Arianespace. We are coming up on the 6th frigate motor ignition due in about a minute. That'll be a short burn, 20 seconds roughly. All 5 satellites tonight going into sun-synchronous orbit. This is a low Earth orbit, around roughly 700-800 kilometers. What happens is the satellite circles the Earth over the poles, constantly moving with respect to the Earth, unlike geostationary transfer orbit, for example. And it passes over the same point on the ground at the same time, so that the images are always acquired in the same light conditions. Couple of numbers. Today's mission, the 315th launch for the Ariane family. The 5 satellites tonight are the 647th, 48th, 49th, 50th, and the 651st satellites launched by Arianespace. And you can see the frigate has lit its motor for the 6th time. There will be one final burn, but we won't see it. Comes after separation. And there is the cutoff of the engine. You saw it shut down right on time. We said it's been a busy year for Arianespace. Just a quick recap of 2019. 9 launches in all. Before tonight, 4 Ariane 5 launches, flights 247, 248, 249, and 250 just last month. Ariane 5 carried 8 satellites this year into orbit, all of them telecom satellites. There were 2 Soyuz missions before tonight, Flight 21 with 6 OneWeb satellites, and Flight 22 with 4 O3b satellites. And there have been 2 Vega missions, Flight 14 with Prisma for the Italian Space Agency, again like tonight, and Flight 15. So 25 satellites in all, not a bad showing. Telecom's Earth observation missions, the Prisma demonstrator in March, and the CubeSats. We go to a film on EyeSat next, and separation coming up afterward. Don't go away.
Sixième allumage et sixième extinction du moteur frégate au profit du
This is EyeSat, a CubeSat-class student nanosatellite designed to study the zodiacal light and the Milky Way. This nanosatellite is a pilot project spawned by the Janus program, initiated by CNES in 2012 to get students at French engineering schools and universities interested in space. We need to train young students through internships. We take in more than 150 interns at CNES every year. We get them working in project conditions like real engineers, so it's very instructive. To develop the EyeSat system, CNES worked with 3 partner engineering schools: INAC for the ground receiving station, ISAUT Super-Aero for the development and operation of the control center, and the IUT Kashan Technology Institute for the mechanical and electrical elements of the payload.
We know that everything we build is going to be flown and operated in space, so it's amazing to get the chance to work on something like that.
EyeSat is carrying 10 innovative technologies that are the result of CNES's research and technology efforts and developed in partnership with industry. It nevertheless remains a resolutely scientific mission. We survey the sky to acquire images of the Milky Way and of what's called the zodiacal light, which is a tenuous light created by sunlight reflecting off interplanetary dust grains. The LATMOS and IRAP research laboratories that help to define the EyeSat mission will be tasked with exploiting data from the satellite. Janus is proving successful in training future space engineers and nurturing entrepreneurial talents, since 5 startups have so far been created as a result of the initiative. I've really been able to gain a great deal of knowledge spanning every aspect of space systems that enabled me very recently to start a new company, which is going to be a CubeSat prime contractor, where we'll be using everything we've learned from EyeSat.
EyeSat and OPS-SAT both due for separation in 4 minutes. Turning to our 5th and final passenger, Angels, due for separation in 7 minutes, or 4 hours and 13 minutes into the mission. It is the first nanosat, CubeSat, built by the French industry for CNES. It arrived here in French Guiana on October 16th with CHEOPS. The generic economical, I should say, and light satellite, Angels, financed and developed by CNES and the Hemeria Group, I believe of Toulouse. Basically an advanced miniaturized location data collection and data relay demonstrator. Now it's fitted with a very small Argos instrument, we're told 10 times smaller than the previous generation. Argos, you might remember, a satellite system which collects and disseminates environmental data from platforms in over 100 countries, I think over 20,000 transmitters in all. Teams from CNES, Hemeria, Thales, Arianespace, and the French Sirlinx group all worked together on the project. Our final video tonight, a look at our final passenger, Angels. We'll be back for separation of OPS-SAT and EyeSat.
This is Angels, the first commercial French nanosatellite designed to collect and locate signals and messages from the 20,000 Argos transmitters around the globe. Developed by CNES and Toulouse-based firm Hemeria, it's a great feat of technology, despite standing only 35 centimeters tall and weighing as little as 18 kilograms.
Nanosatellites are also a development philosophy based on building faster and cheaper while taking a little more risk. And for a firm like Hemeria, it's all about finding the right trade-off between cost schedule and the amount of risk the market is ready to accept.
Hemeria was selected after a CNES request for proposals in 2016, geared towards taking France into the growing commercial nanosatellite market.
CNES is engaged in this endeavour to support the network of small firms in the region and nationwide, and to meet this new demand from the market.
To this end, CNES and Hemeria have adopted innovative ways of working, setting up a project platform with more than 25 people, including 5 engineers from CNES, and using short, iterative development cycles to improve the design and production phases. CNES has also brought Hemeria its research and development expertise.
We've been able to draw on expertise in all fields. from materials and thermal analysis to management of the flight-ground systems interface and the control center.
With Angels, Hemeria is therefore on track to build the future CNES constellation of 25 nanosatellites, planned for launch in 2022 and designed for the Internet of Things. I can't wait to see it in orbit with the Argos Neo payload. Angels is expected to deliver data for 2 years.
A little over a minute until separation of OPS-SAT and EyeSat, both launched here from the CSG, the Guiana Space Center, the world's only dedicated commercial space base. The base was chosen back in 1964 among 14 possibilities, including Australia and Scandinavia, when the Europeans wanted a new base. They found everything they were looking for here. We mentioned a large opening on the ocean, but that was not all. They wanted a low population. I think even today, 270,000 people in French Guiana. Most of the land is forest, as you may have noticed. They wanted nearness to the equator, which allows a launch to benefit from the Earth's rotation to get more quickly into orbit. The Earth spins and adds 400 meters a second to a launcher getting into space. The site here also free from hurricanes and earthquakes. We're south of the hurricane zone. It also offers hills nearby where radar and telemetry facilities can be installed to follow the launcher, and that we're going to see in just about 2 minutes because we're going to go up to that facility. Meantime, we await confirmation of separation of EyeSat and OPS-SAT. Again, a moment of high concentration here in Jupiter, and I imagine at all the EyeSat and OPS-SAT facilities around the world. The animation you see together, separated, one on either side, OPS-SAT and EyeSat, but of course we're waiting for the official confirmation from the DDO. That shouldn't be long in coming. These dedicated teams who've worked so hard on their projects, following the final moments, again awaiting word from the DDO that their satellite has successfully separated from the frigate vehicle, just like CHEOPS before, and COSMO-SkyMed before that. Jupiter Mission Control, we mentioned, it's like a control tower of the space base, like an airport, and the brain of all launch operations. One other place, and the last one we want to show you, where the teams are hard at work tonight, we mentioned, this is the CVI,
Confirmation de la séparation des charges utiles EyeSat et OPS-SAT.
And the DDO has called out confirmation of separation of OPS-SAT and EyeSat. And you hear the applause. So that's good news. Meanwhile, we're looking at the Quick Look Telemetry Display Control Center. It's on a hill just behind us here in Jupiter. Remember, when choosing a space base, the Europeans wanted nearby hills for radar and telemetry reception. These teams have all the means for receiving and processing, storing, and analyzing all the data coming in every second from the ground stations along the Soyuz flight path. Remember, we've been talking about the stations that follow the launcher. The Canadian station Saint-Hubert, Mauritius, which you just saw. We've been picked up by that antenna. 2 antennas over there. Right now, these teams are monitoring all the key flight data they are receiving and are reporting the flight status of the launcher back to the teams here in Jupiter. Also to the flight desk and to the Launch Complex Operations Manager. All part of the great information flow from points all across the base back in here to Jupiter. You see how Jupiter deserves its name as the nerve center of the space base. Separation of Angels, our final passenger, in just about 6 seconds. The Angels people, just like the OPS-SAT and CHEOPS people before them, all eyes on the computer screens and ears on the telephone. There's the computer animation, separation of their satellite. It is a small one compared to the mothership, as you see. I think 19 kilos. And the DDO will confirm that. And he has confirmed it. You see the applause, you hear the applause. The final good news. Soyuz completes her very long and very complex mission with successful separation of Angels. So Angels joining her co-passengers, CSG-1, CHEOPS, EyeSat and OPS-SAT, beginning life thanks to Soyuz and Arianespace. Smiles, hugs, handshakes all around. Here in Jupiter, yes, very happy teams. Kisses, cigars, and champagne will be forthcoming, no doubt.
Confirmation de la séparation de la charge utile Angels.
Arianespace successfully delivering once again on her final mission of the year, 5 new satellites making their ways to their final orbit. So from the tense minute just moments ago, you can see the change here in Jupiter, very buoyant, all across the Space Center. And no doubt at the points and posts where people are following the launcher and satellites. Here's another replay of the launcher. Several launch replays for you. Work is just beginning, or soon will be, at the different ground stations for all our passengers this morning, and the other sites around the world where their first maneuvers are being monitored. We're waiting for the traditional post-separation speeches, and I see Stefan Israel making his way to the podium. He will speak first.
So, ladies and gentlemen, distinguished guests, Arianespace is delighted to announce that the 5 satellites entrusted today to Soyuz have been safely separated as planned on their targeted sun-synchronous orbit. For our 9th and last launch of the year, success is here for our customers and our partners. Congratulations to all of them. This success shows Arianespace's ability to deliver for European institutions and to orbit innovative small satellites. Let's be proud of this new achievement, which comes in a perfect timing after the success of Space 19+ under the leadership of ESA and its Director General Jan Werner. We are delighted to have orbited COSMO-SkyMed Second Generation, our main passenger for this flight. COSMO is the 4th satellite we launched for ASI. It also marks the 9th mission for Italy, the last one being Prisma, orbited with a Vega launch vehicle earlier this year in March. I would like to thank TAS, our direct customer for the launch of COSMO-SkyMed Second Generation, and congratulate all TAS teams for this new state-of-the-art bird handed over to Arianespace. This is the 162 TAS satellite launched by Arianespace. Let me for sure thank as well the Italian Ministry of Defense and ASI, the Italian Space Agency, who have entrusted Arianespace with this key mission for Italy. In parallel to an important event organized by ASI yesterday in Roma, we welcome here at CSG Admiral Giuseppe Abamonte, Director of the Italian Secretariat General of Defense. Dear Admiral, we are very grateful to have you with us today here in CSG. I know that all our Italian friends and partners are now impatient to launch the second COSMO-SkyMed satellite on board on a brand new Vega C. We will deliver as well. For having entrusted our Soyuz launcher with CHEOPS, let me extend my gratitude to our second customer of the day, our dear ESA. CHEOPS is the 74th satellite Arianespace has launched for ESA since 1982. I want to thank Gunther Hassinger, Director of Science, for his renewed trust, his enthusiasm as well, and all what he delivers to Arianespace with key missions. We have done together BEPI, we will do JUICE, and many more. To the benefit of ESA, CHEOPS was built by Airbus in Spain, and we have a lot of Spanish friends here today with us, and it represents the 128 spacecraft we launched for Airbus. What a partnership. I would also seize the occasion to welcome 2 of ESA's Swiss guests. Mr. Joseph Widner, Deputy Director of the State Secretariat for Education, Research and Innovation of Switzerland, as well as Professor Didier Queloz. Didier Queloz has just been awarded the Nobel Prize. It is not nothing, the Nobel Prize, for his research on exoplanet. He is with us today, and we are very proud to welcome Didier in the Guiana Space Center. It is an honor to have you among us today, and we are happy to celebrate what now CHEOPS is going to deliver for the progress of science. Alongside our two main passengers, 3 auxiliary payloads shared their flight. For having entrusted OPS-SAT on our Soyuz on behalf of ESA, let me thank Tyvak. OPS-SAT represents the first satellite we launch for the launch aggregator Tyvak, and it will prefigure the next ones to flight on the Vega SSMS next year. So thanks to Tyvak as well. Finally, I would like to thank CNES. EyeSat and Angels represent the 16th and the 17th satellite we launched for the French Space Agency. I extend my gratitude to Hemeria, also an innovative company who jointly developed with CNES the satellite Angels. In this regard, let me express my deepest gratitude to Caroline Laurent, Director for Orbital Systems at CNES, and to Philippe Gauthier, President of Hemeria. Arianespace is stepping in the market of the small satellites. We will have many other opportunities to show our ability to deliver with our family. Ladies and gentlemen, this third Soyuz from CHG and our last flight of the year brings to 23 the number of missions performed with Soyuz from the Guiana Space Center. The first one was in 2011. For all what we have done together, I would like to express my gratitude to our Russian partners, Roscosmos, RKC Progress, NPO Lavochkin, and Senki for their continuous cooperation. Let me also congratulate all the European teams who, alongside our Russian partners, have greatly contributed to today's success. Our ground contractors here in French Guiana, and for sure our daily partner in CSG, CNES. Of course, for this last launch of the year, I want to pay my tribute to all my Arianespace colleagues for this new success, for all the hours they have delivered without counting these last days, for their professionalism and their commitment. Thank you very much to all of you. So I now like to welcome on stage our customers and partners. Thank you very much.
Ladies and gentlemen, distinguished representatives of the agencies, of the Italian Minister of Defense, of the industries, and women and men of the great team of COSMO-SkyMed Second Generation in Italy, and especially here in French Guiana. It's great to be here at the European Spaceport to report on behalf of the Italian Space Agency President the first successful results of this 5th COSMO-SkyMed Second Generation satellite, the first of the second generation, and another remarkable step for Italy and for its role in Earth observation from space. And let me say, it's great for me to be back in Kourou after the successful mission Hyperspectral Satellite, our mission, launched in March 2019, and now for another successful launch. Italy has given us, to the Italian Space Agency and to the Italian Minister of Defense, a task to guarantee the operational continuity of the COSMOS satellite constellation for civilian and defense Earth observation services, and to consolidate the excellent scientific and technological know-how reached up to now by Italy in the Earth observation sector with radar techniques. COSMO-SkyMed Second Generation confirms the global coverage of the Earth operating in any atmospheric and light condition, night and day, and provides, compared to the first generation, increased the number of images, enhanced the quality of additional capabilities, like an example, the full polarization, and a very high response time, unsurpassed characteristic so far by any other Earth observation system. After the first COSMO-SkyMed satellite launch in 2007, the constellation of Italian COSMO-SkyMed has been completed in 2010. The satellites are showing outstanding performances exceeding the lifetime expectation, demonstrating how a reliable design can go beyond the planned lifetime. After 12 years from the launch of the first COSMO-SkyMed satellite, the second generation is coming to boost the system capabilities with improved performances. And furthermore, in 1 year, the second satellite of COSMO-SkyMed second generation will be launched on a Vega C launcher, confirming the capabilities of Italian industries. The second generation of COSMO-SkyMed represents for us a milestone in radar remote sensing technology, providing in a dual-use mode a revolutionary understanding of our planet that will strengthen our country leadership in the field of satellite Earth observation and its services and applications as an effective tool for economic growth and social well-being. Today, we are at the dawn of a new era, an era that will bring new challenges and opportunities, guaranteeing to the national community the continuity of services already available and new one, providing a great improvement in a broad range of applications like land management, service, national security, disaster prevention, protection of the environment, and in general for the care of our planet. COSMO-SkyMed, the second generation, has been developed under the aegis of my agency, together with Italian Minister of Defense, by a joint venture of Italian industries, led by Thales Arianespace Italia, responsible for the satellite and the system, and Telespazio, which set up the ground segment of the mission. The meaningful participation of Leonardo and of several Italian small and medium enterprises provided a strong contribution to the program. I would like to express my full appreciation to the industrial consortium for the excellent work done, and to Arianespace for the perfect launch services they did once more, delivering our satellite in orbit. I would like to thank also the colleagues of the Italian Space Agency, of the Minister of Defense, that never gave up during difficult moments that every challenging space program has to face. They continue to do their best to have the greatest and most powerful Earth observation radar for dual use ever built. Concluding, COSMO-SkyMed and the second generation is the result of the joint effort of a wonderful team of industry and institutions, composed by technicians, engineers, young and old professionals that together with passion spent their effort for a challenging common adventure. This success is dedicated to them, to their work, ingenuity, dedication that have allowed us to obtain such an outstanding result. Now, it's time to go to work for COSMO-SkyMed and for Italy, and thank you all.
Ladies and gentlemen, it's a really great honor for Thales Arianespace to be here today, celebrating the launch of the first satellite of COSMO second generation. It's a really great honor for us to be here in what we call an important milestone for Arianespace, of course, but for the scientific community, for the whole industry, Italian industry, and for the customer too. Let me give you some technical data. COSMO is an Earth observation mission based on X-band synthetic aperture radar sensing capabilities. COSMO Second Generation represents the follow-on mission of the COSMO-SkyMed program. The first generation, you know, consists of 4 satellites. The first one launched in 2007, and since then, this constellation has been our guardian angel from its orbit at 620 kilometers altitude. But just some words. In fact, what do we use COSMO for? COSMOS images were used in 2008, but the United Nations and the humanitarian organization after the terrible earthquake in China and after the Nargis hurricane in Burma. Again, COSMO-SkyMed was there a few months later to help the rescue squad after the Hurricane Anna and Ike devastated Haiti. These are just some examples, as well as manage environmental risk, damage assessment activity, rescuing operation, infrastructure monitoring, agriculture and forestry, surveillance and security. Now it's time to grow and to have one more satellite in the sky, a new generation of a new brand product. Thanks to the new technologies developed by Arianespace in our sites in Rome, Milan, Turin, and L'Aquila, COSMO Second Generation satellites will grant the operational continuity of the service provided in the last 12 years by the constellation of the first generation. COSMO Generation will also provide our customers with the new and more advanced observation capability in terms of image quality, resolution, information content, pointing agility, and systems response time. These steps ahead have been made possible thanks to the implementation of new technologies in the antenna, in the radar, and in the satellite, allowing to fulfill many operational needs and reaching larger community users. Let me finally remind you that this is a system designed to address the needs of both commercial and government customers, as well as the scientific community. I'm ending my short speech with one further reason to be proud today. You know that this satellite launched this morning for Italian Space Agency and for the Italian Minister of Defense is the primary passenger of the Soyuz launcher, but it's well known that there are additional passengers on board that make this launch a special event for Arianespace, CHEOPS for the European Space Agency, and ANGEL for CNES. In fact, we have been involved also in their development, and they both use TAX technologies, so you can understand how much is important these days for us. Now it's time to conclude and to thank a lot of people. First, I would like to thank my people, all the amazing Thales Arianespace employees, who led us to this great success, a large international team with a great spirit of cooperation and team working that has made possible this success. I want to thank any single one of them. I thank Telespazio team that has realized the ground segment, EGEOS that will commercialize the data all over the world, and Leonardo that provide state-of-art equipment as a power supply and star sensors. We all together faced and managed the most complex situation in the best way. I want to thank Arianespace, hosting here for their excellent service. Thank you. And last but not least, I thank our customer, the Italian Space Agency, and the Italian Minister of Defense for having teamed with us from the very beginning to achieve this great success for Italy. So, Godspeed VS23 and all these passengers. Go.
Dear ladies and gentlemen, it's a great pleasure to stand here the second time in my career and give a victory speech. And I would first like to congratulate and thank the teams of all 5 satellites, all spacecrafts that we have successfully put in orbit. And this family of satellites with a mother satellite, a baby satellite, or a child satellite, and 3 baby satellites is really symptomatic for the family of teams that has come together here and has also learned to know each other for the last few days. And we come out here as a real family, and this shows how cooperation on the European landscape is really working in a positive sense. So I'm really very glad about that. And I would like first to say that we are extremely relieved that also, at least we now know that CHEOPS is working. All systems are green. All this telemetry is stable. Temperatures are fine. Powers, voltages are fine. So everything is really good to go. And I would like to express a series of thanks to a lot of people who have made this possible. The first thanks I would like to express is to the PI, Willy Benz. Willy told me that he has put together the idea of CHEOPS about 10 years ago on a single sheet of paper, and now see what has come out of it. He led a team of scientists and engineers, and it still leads a team of scientists and engineers. And you have seen some of them, their powerful response to the success. And I would like to say that in particular, I'm impressed about the breadth of the team, the young new generation coming in, and in particular also the fact that a lot of important roles are taken over by female scientists and engineers. So this is really the future for all of us. I would like to thank the Swiss Space Office in the secretary. Sorry, I have to put the name exactly in the State Secretary for Education, Research and Innovation of Switzerland, which is our partner in this mission. This is the first mission which is really done in full partnership between one of the member states and ESA, and this has been a very interesting and important experience. And so I thank the Swiss Space Office for supporting Willy Benz and the team in this enterprise, and for also leading cooperation of a total of 11 member states. As usual, in the ESA science program, ESA is building the satellites and launching them through, or helping Arianespace to launch them. And the instruments are provided by the member states, and so it is always a very important cooperation. But in this case, it is an even more cooperation important because of the leadership of one of the agencies. I would like to thank the scientists and the engineers, and the scientists represented by the chair of the science team, Didier Queloz, who has brought his energy with him and has really energized all of us. And so thank you for that. And you also brought half of the Nobel Prize with you. And that, I think, will also be a very good basis for excellent science in the future. I would like to thank industry, because industry is so important for all we are doing. And I would in particular like to thank CASA, Airbus in Madrid, our partners. We live in the same city. And in particular also for the fact that CHEOPS was built in time and budget, something that is really very important for us to carry on in the future. And then we are able to expand on our important activities. I would like to express an extremely and really heartfelt thanks to Arianespace on one hand for, again, a beautiful delivery of all of our spacecrafts in orbit. But in this particular case, with the Soyuz launcher, also our Russian colleagues, which have done a great job. And you know, all this care that we had yesterday, and the fact that they were able to fix this over a very short period of time. I would personally like to apologize that I have contributed to some of the turbulence yesterday, which hopefully has been smoothed out today. So thank you very much for this. Then I would like to thank all of the ESA member states, not just the ones who are participating in CHEOPS, but 22 member states are really the ones who are carrying our program forward. They are funding the science program in a mandatory fashion, so they all have to contribute, and so they are also part of CHEOPS and of the whole science program. And that brings me to the ministerial in Seville that has been mentioned several times already, an extremely, almost historic success, not just because we got a historic record subscription of 14.5 billion euros, 0.1 billion more than ESA was asking for. So this shows also the trust that the member states are putting into ESA. But also there were organizational changes to bring us all forward, to improve and to make us even better. And I think the success today shows that this trust is really worthwhile. And I would like to come back to the DG's motto. Jan Werner in Seville has brought the motto for the next period, which is inspiration, competitiveness, and responsibility. And I think the ESA program can be represented by these three topics. For instance, competitiveness is all the things that we are doing for industry, that we are doing in order to enable European industry to foster space activities. Responsibility is what we are doing for Earth observation, for climate change, for space safety and security, which has come a new program in ESA. For the first time, we want to deorbit a satellite, and also we want to take actions against near-Earth object asteroid impact and also against the solar aspect. Let me come to the responsibility part, because this is actually also connected to our mission. When you look at this complicated roller coaster orbit that we are seeing there, we first went up, then we went down again, went up again. One of the reasons for that is that we have deposited some of the structures that we brought into orbit and made them possible to deorbit. So we will not leave any space junk after this mission. We will only bring active stuff up there. And I think this is a very important message for the future. I think we all have to come into this mode that we have to clean near space, because otherwise we will not be able to do more space activities. So this mission is also representative for a new era in that. And so then let me come back to the science program. The science program is the one which is basically responsible, one of the ones responsible for inspiration. And we have seen the inspiration today. The exoplanet science is really an extremely important field. CHEOPS is the first one of a series of 3 exoplanet missions, Plato, Ariel, but also the James Webb Space Telescope, which we will launch from here, from Kourou, in not too long a time, will dedicate a large amount of time to the detailed studies of exoplanets. So this is really a place to watch for our children and children's of children. I think this is a real important field that is skyrocketing up. Now, the other side of the Nobel Prize, which I mentioned before, has been given to cosmology, to Jim Peebles, who was responsible for some of the early analysis and theory of cosmology. And I'm very proud and happy to say that ESA is also very strong in cosmology. We will launch the Euclid mission in 2022, which is dedicated to study dark energy, dark matter, black holes. We will prepare the next big flagship missions, Athena and Lisa, which are studying the same phenomena and bring sound to the cosmic movies. So this will be a very exciting for the other side of the Nobel coin. And then in the final sequence, in the very important element of solar system science, because our solar system is also extremely interesting, we will launch JUICE in 2022, which goes to the icy giants of, the ice planets of Jupiter, and Solar Orbiter, which will be launched in February next year, that goes to the sun and studies the sun from the angle above. It can look at the poles of the sun. And I would like to end with one very exciting mission, very close to my heart, that we have actually invented and developed just last year, which will fly together with Ariel. It's called Comet Interceptor. You may have heard about interstellar visitors, rocks that are coming from other stars. And this Comet Interceptor mission was born out of the idea maybe to visit a very fresh comet, a comet that has never visited the solar system before, or an interstellar visitor. And so bear with us in the next 10 years. There will be really very, very much more exciting science, and this is just the beginning. Thank you very much.
Buenos días a todas y a todos. Bonjour. Good morning, everyone. What I'm going to say basically is I'm not going to go back, to describe CHEOPS, and what it's going to do. But I'm going to say that we are very happy because of the way we have done it. And like in the past, when we embark ourselves in discovery missions, this is about the same. And always this type of projects are collaborative projects. It's cooperation which makes the projects work. And in this case, I think the CHEOPS is an example of collaboration between all Europe and the different institutions and the different sites. For example, more than 22 companies have collaborated and participate in this project, out of 11 or 12 different countries. The scientific community that help with the requirements and the definition of the mission, the ESA. And I want to thank the ESA, not only because it's my customer, which is, is a reason itself, because ESA and Dr. Hasinger in the science organization did something different, work in a different way. They dare to change the rule of the games and start with this type of mission, fast mission, which are a different way of working. And when we talk about innovation, we think about technology. But innovation is also about changing the way of working. This is also innovative. And in a competitive environment of space, as we see every single day, it's very important that we change our minds and we change the way we work. Otherwise, we will not be competitive. Otherwise, we will not achieve the result we want to achieve. So basically, we are pleased and we are happy because for Spain, and I say it's not a country, it's not a flag, but for us, for Airbus Spain, it was the first time that we led, we are leading a mission for ESA. And as you say, my dear customer, we were able to deliver on time, on cost, and on quality. So for that, I think we can rely on Airbus. Airbus has all the expertise of bringing people and pieces together to get to the result and deliver on time, on cost, and on quality. Thank you very much.
Ladies and gentlemen, the smallest and the latest. I'm very moved to be here today, and actually I think that every launch is like a first one. Every successful launch is like a first one, and it's very emotional. I am very moved too because 1 year ago I was here representing French Ministry of Defense, and that Admiral Abramonte was here too, and we were launching the new generation French military optical imagery satellite. And I am very happy today and very moved because I know that once in a few weeks or a few months we will be able to, our forces will be able to exchange radar and optical images, and it is very important for them. So I think it's a sign of a very strong cooperation and a very strong relationship between Italy and France on military space. So congratulations to you, Admiral. And I want, for this beautiful launch, to thank deeply the teams of Arianespace and its teams, but also the Russian teams and the French and Russian teams of Soyuz in Guiana, and the teams of the CNES Guiana Space Center for this wonderful launch. I was here mostly for EyeSat and Angels, but congratulations to ESA too, because as a member state, France and CNES are also part of CHEOPS, and I know that Airbus France and Thales Arianespace have technologies embarked in CHEOPS. But I was here mostly for EyeSat and Angels, those two very small but very different satellites, the one being an educational program and the other one, the really number one of an industrial satellite firm and an industrial filière. And so I want to congratulate all the teams that worked on this project. On behalf of Jean-Yves Le Gall, who just sent me a message, I want to congratulate all CNES teams today. So I guess it's all CNES teams. Marianne, I think it's the space orbital teams and the Guiana space teams. And I would like to wish a long life to Hemeria, our beautiful small company, but also to U-Space, the very startup company which emerged from the Janus and from the EyeSat project. And I would like to take this opportunity to wish success and a long life to all French small companies and startups that are gathered in the French New Space Factory that came here to Guiana and made the trip today. And at last, I will congratulate every one of you and for this success. And since next week is Christmas, I will wish you a Merry Christmas to all of you. Thank you.
Also, ladies and gentlemen, what an impressive European team. And I want to highlight once again that Europe goes up to Switzerland. And because for CHEOPS, we have had the pleasure to have Gunther and Fernando speaking about the project, but I want to highlight the huge contribution of Swiss to this project, and we have with us key player of Swiss. So thank you very much for your dedication to this project. So now it is time to have a little break in the Guiana Space Center and for all our friends and partners. Fortunately, this break will not last too long because we will be back here in CSG in less than 1 month. Ariane will open the show in 2020, our dear Ariane 5, and we will do it for two very good friends of Arianespace, Eutelsat with Connect Satellite, and our dear Indian Space Agency, ISRO, for GSAT-30. So this will be January the 16th, and we will start the year for these two customers. Thank you very much. Merci beaucoup. Passez de bonnes fêtes et soyez fiers de tout ce que vous avez fait cette année. Bravo.
Happy Christmas and be proud of everything you've done this year.
Well, it has been a very long evening, but a very exciting evening. We're very glad you could share it with us. To see Soyuz in a very complex mission successfully orbit 5 new satellites, reigniting her frigate engine 7 times to do it, something which had never been done before here in Kourou. So Arianespace's final launch of the year, a big one, and we close out the year in style.
On achève effectivement avec beaucoup de classe cette année 2019.
This is quite a way to end 2019.
Pour saluer un homme qui a été à nos
There's somebody I'd like to talk about who has been with us in the past and has decided actually that he would choose this wonderful moment, VS23, to retire. So Claude Bernard, thank you, Claude, for everything that you've done, and thank you for being such a great friend, and I know that you will always be a friend.
We all love you. Good luck to you, and keep in touch. All that's left for us to say is have happy holidays and a very good New Year. We'll see you back here in January. So on behalf of everybody here at the Space Center, Joshua Jampel, Thierry Bouvard, thanks for being with us. We'll see you again next time.
Bonne fête à tous.
el cohete Soyuz levanta sus 309 toneladas de peso para poner en órbita el satélite CHEOPS a 700 kilómetros de altitud.